Okay, just making sure you saw the end of 46, cosine inverse. Let's go on to the next example. And okay, first thing you want to do is draw your triangle. And label angle A, 58 degrees. Side A is equal to 11.4. Angle B, I usually like to put left to right, top to bottom. B is equal to 12.8. And that's it. Your answers. It says determine the remaining measurements. A lot of people, you need to find everything. Okay, so keep in mind your answers of side and angles should be correct to the nearest tenth. Tenth is 1 decimal place. Okay, got a lot to do. First thing you want to see is, hey, you're given a side and an angle opposite that side. That's law of sines right there. So let's set this up. It's going to be the sine of 58 degrees over 11.4 is equal to, we have to use B. So again, it's going to be the sine of B over, so anytime you're left sine of B, you have to know ahead of time that you're going to have to use sine inverse. Okay, constant becomes your coefficient and you're cross multiplying. Equals, constant becomes the coefficient. Undo multiplication with division. And this is 11.4. And angle B, we're going to go right here to angle B. So this is C. Angle B is equal to sine inverse of everything that's here. Let's put that in our calculator. Okay, making sure you have everything in parentheses. Press enter. And we have a very small angle. Make sure you put it down. Angle B is equal to 11.6 degrees. So be careful. I saw a slight error. I changed it. 11.8. Let's see what that angle B is, which is 72.2 degrees. Right away, we're dealing with two acute angles, 58, 72.2. We want to test for, so if I were to write D, we want to test for two triangles, or test for, two triangles. In order to do that, we're kind of looking at this original, is that angle B is somehow separated. There's some type of hidden angle up here where it's going to be another name for angle B. We'll have two angles, B1 and B2. Now, it's actually kind of reflected inside. These two angles, the premise is that it's down. Actually, the angles are rather down here to figure it out, that this is B1, B2, because two angles lie on a straight line. So to find B2, it's going to equal 180 minus B1. And this now is B1, because that's our first angle. And we put this in our calculator, which would be 180 minus 72.2. and we get the second possible angle is equal to 107.8 degrees. Okay, so what we're going to do now is a lot of work, and we're going to have to go check it. After we test, we need to see if we can get three sums for two triangles. So here we go. So we're going to look at angle A. Here's our plan. And I'm going to call this E. We're still testing for two triangles. Angle A is our given angle, so that cannot change. Plus angle B1 plus angle C1, because now we have a different A, we're going to have a different C, if that's equal to 180. And we also have to test for B. So we'll keep these triangles separate here, and I'll have the other ones again. And we have to see if angle A plus angle B2, again, will match with C, angle 2, if they also equal 180. So now we're working horizontally. So let me put the B1 in, because I'm already in blue. 72.2. We don't know what this is. We're just going to show all the work equals 180. And we know what B2 is. I want to make sure I get these values and don't mess up. Okay, we don't know what this is. So here we go, back to black. And this is our given angle, which has to remain constant in both. Okay, so angle C1, and this is going to be plus angle C2. Okay, so angle C1 is going to equal 180 minus the sum of these. Okay, so you could put that in parentheses, 58. And the same thing goes here. Angle C2 is going to equal 180 minus the sum of these. And put these values in a calculator. Okay, so the first angle for C1 is equal to 49.8 degrees. And let's do second enter. Be 58 plus, just typing over, 107.8. Ooh, we got two measures for angle C, which means two triangles do exist. We have to go find the other measures. Two exist. Okay, so now we have to find, they only gave us A, we have to find A1, A2, and we're going to use law of sines to help us with that. Okay, so let's go ahead and find side B, B1. Okay, so we have to find side C, C1, and side C2. And we're going to set up our proportion. Sine of 58, let's go back to black, it's easier. Sine of 58 over 11.4 is going to equal the sine of our angle C over, and we'll just call it C sub 1. We'll put the 1 and 2 after. It'll be less confusing. Cross multiply to solve. C sine 58 equals 11.4 sine 41.9. Divide by sine of 58. Sine. This is in your calculator. And now we'll go ahead and put that this will be C, the first C value. Okay, and let's put this out clear. 11.4 sine of 49.1. Okay, some drama going on here. Okay, I had to reset the calculator. And this is what we have. Let me just make sure we put it in correctly. We just put in that first C value. Okay, so we have that C1 is equal to 10.2. And let's go ahead and find the other possible value for C2. So we have EFG. And we'll leave it here. We're going to still use the same ratio that we're given. Sine of 58, always use your given, over 11.4 equals this new C value, which is the sine of 14.2 over our C value that's unknown. Cross multiply to solve. C sine 58 equals 11.4 sine of 14.2 divide by sine of 58. Similar. Just take all your steps. And we'll have C is equal to, and we'll put this in. What's nice is the numerator is the same. So I'm just going to use my second inner feature. And then I'm just going to change the 14, the number inside parentheses, which is now 14.2. There we go. So 0.2, enter. And we get our second possible C, which is 3 round to the nearest 10th, 0.3. And these are your values. Okay, so let's look to make sure we solved all our angles, all our sides. A is only one side that's given. That's untouched. But because there's the split between angle B, there's going to be 2 side B's, 2 side C's, and 2 angle B's and 2 angle C's. And that's what we have. And we are done.